Hello 8th graders, in this video we are going to go over a couple of different ways to write down elements. They are called periodic table notation and isotope notation. They cover ELRs 7.1 and 7.3. This is a lot like reading a nutrition label because a nutrition label tells you what's in some food in the same way that these types of notation tell you what's in an atom. So when you're looking at the periodic table, all those numbers are telling you how the atom is made, and it's our job to learn how to read that. The first place that we have to start is with a little review. At the top of your page, there's a couple of spots that we're going to fill in. The first thing we need to talk about is how important protons are. Protons define the element. In any kind of atom, you can have a different amount of neutrons or electrons. Those are important, but not nearly as important as the protons. Everything on the periodic table is organized around the proton. So the big number that's up there, that tells you how many protons. If you have an atom with 12 protons, you're talking about magnesium. It doesn't matter what the other things are, it's magnesium. That's the identity. If you have some element that has 7 protons, it's nitrogen. Who cares how many electrons or neutrons? Protons are the thing to care about. So take a look at this element that's on my screen. It has 3 protons in it. What kind of element must it be? Take a second to think about it. This must be lithium. Since it's got 3 protons, lithium is number 3 on the periodic table. What I need for you to do is on the side of your notes, there's a little box. Please draw for me a sketch of boron that has 4 neutrons and 4 electrons. Pause this video now. If you're still watching, you're ready to check. Since boron is number 5 on the periodic table, it's going to have 5 protons, and then the 4 neutrons live in the center with it. So there's my 5 protons. I've got 5 neutrons to go with it. That makes our nucleus. And then we need 4 electrons around the outside. The other thing that we have to review and talk about is what it means to be neutral. So let's remind ourselves, protons have a positive charge and electrons have a negative charge. So take a look at this element that's on my screen. We have 3 pluses in the center and we have 3 minuses around the outside. Since we have 3 pluses and 3 minuses, you can think of it like they cancel each other out. And that's what neutral means, when all of the pluses balance out all of the minuses. So take a look at this element. Pause the video and think about what kind of a charge would this one have. So since the red ones are protons, we would have 5 pluses in the center, and the electrons, there are 4 of those. If we have 5 pluses and 4 minuses, that means that we have 1 more positive than we do negative. So this would be a +1. So an atom is neutral when the positive is the same as the negative. Pause this video if you need to write these notes down. Off to the side, there's a spot for you to try this one now. Please draw for me a carbon atom that has 6 neutrons and a -1 charge. If you're still watching, you're ready to check your work. So carbon, of course, has 6 protons because it's carbon. That's what makes it carbon. So it's going to have 6 pluses. Well, in order to be neutral, it would have to have 6 minuses as well. But this isn't neutral, this has a -1, which means that it has more minus than it does positive. We can't just take away a proton because then it wouldn't be carbon anymore. So we have to change the electrons. So in this element, we're going to have 6 protons, 6 neutrons, and then around the outside, we have to have 7 electrons, since it needs 1 more minus than the plus. Now that we've got our review taken care of, we're finally able to talk about some notation. We're going to start with one of the more simple elements, helium. What you see on your screen is called isotope notation, and it's a way to write about a specific atom of helium. So we're going to talk about this particular atom of helium. Remember, protons have a mass of 1 AMU, neutrons have a mass of 1 also, and electrons have no mass. And those numbers are where we get our isotope notation. It's telling us how much mass things have. The first part that we care about is the symbol. So this, of course, is helium. Because it's He, we can also use it to look at the periodic table, to look at some other information too. The next thing we care about is this thing called the atomic number. It's the bottom number, and it tells us how many protons the element has. Yeah, the symbol tells us 2, but it's nice that it's here so that we don't have to memorize anything. We know it has 2 protons because that's what the atomic number tells us. If this element is neutral, which for this class right now, everything is neutral, that means that our electrons have to be the same amount. So this is going to have 2 protons and 2 electrons so far. The neutrons are the little tricky part. That's what we need the mass number for. So the number on top tells us how much mass this atom has. Remember, protons and neutrons are each only 1 AMU. So if this helium has a mass of 4, and we know it has 2 protons, the 2 that are missing have to be neutrons. So 4 minus 2 is going to tell us our neutrons. So we have 2 protons because of the atomic number, 2 neutrons because 4 minus 2, and 2 electrons because it's neutral. Pause this video if you need to record any notes. Now it's your turn to get a little practice. Towards the bottom of your paper, you have 3 isotope notations. I need to know how many protons, neutrons, and electrons are in each one. Please pause and try that now. If you're still watching, you're ready to check your answers. Here's what you should have. Please call me over in the classroom if you are getting any wrong answers or not sure how I got these numbers. Now let's go on to the lazy version. There's another way to write isotope notation that cuts a little bit of a corner. Remember how we have the symbol already? And we know if we have a periodic table that helium is number 2 on the periodic table, which means we don't really need this extra 2 as long as we know that it's helium. So if this is helium and we have a periodic table, we could write this way. If we wrote helium-4, we know that this is helium with 2 protons and a mass of 4. And it gives us all the exact same information. At the bottom of your page, there's a question that I need you to answer. How can you still tell the amounts for the other parts of the atom from this notation? Please pause this video and answer that question before we go on to some practice. The 3 elements that you just did the isotope notation practice for, we're going to go back up and I want the shortened isotope notation. So I've got it started for you. Underneath your work, please add the shortened isotope notation for each one. If you're still watching, you're ready to check your answers. Here's what you should have for all 3. Please call me over if you're getting any different answers. Now we're going to take a break from this video and go do some practice on a website. In Google Classroom, there is a link that says Isotope Notation Practice. When you get there, you're going to see what is on my screen. There are a number of blanks that are not filled in, and it's your job to figure out what goes there. On the very top, there's the shortened isotope notation. Then in the middle here, there's the full isotope notation. And then at the bottom, your job is to figure out how many protons, neutrons, and the atomic mass. When you're ready, you can click the check button to see how you did. Please come back to this video when you're finished. The other type of notation we're going to talk about is called periodic table notation, and this is the one we're going to use the most. Isotope notation was for when we're talking about a particular atom, like this atom has this many protons or neutrons. Periodic table notation talks about the entire group. So we're going to talk about like every helium on the planet. So the top number still tells us the protons and the electrons, because if it's helium, it's got 2 protons. That's what defines helium. But the number on the bottom tells us the average. So some heliums are a little heavier because they have extra neutrons. Some are a little lighter because they might be missing one. But if you were to take a sample of helium and take the average, this is what you would get. That's the number on the bottom of the periodic table. So we can use this to figure out all the same stuff that we did with isotope notation. The top number tells us protons and electrons, but for the atomic mass, we have to round it first, since it tells us an average. So if you round it, it'll tell you the protons and the neutrons together for the most common of that type. Here's an example. Let's say that we have copper, and the atomic mass on the bottom is 63.546. That means if you took a scoop of copper, some of them would be a little heavier, some would be a little lighter, but they would all have 29 protons. But the neutrons are what's throwing off the mass. So in order to find protons, neutrons, and electrons, we'll start with the protons, because that's what copper is, 29. This is going to be a neutral element until we change that later on, so it's also going to have 29 electrons. Now to find the neutrons, we need to round 63.546 to the nearest whole number. So looking to the right of the decimal, 5 is greater than 5 or more, so we need to round up. This will round to 64. So when we round to 64 and take away the protons, we'll get 35. On your paper, there are a few practice questions that I need you to try. I want to know the number of protons, neutrons, and electrons, and I threw in a few isotope notations for practice as well. Pause this video and come back when you're ready to check. If you're still watching, here's what you should have. Remember, I need you to call me over if any of these look funny or you need some help. Once more, you are going to pause this video and go off to another practice link. So in Google Classroom, there's another link that says it's elemental. I need for you to choose the settings like you see on my screen. I'd like you to practice with 10 questions. Make sure the first 3 boxes in this row are checked, but don't check the nucleons box, and check no on the last one. It'll tell you how you're progressing throughout the way. Come back when you're ready to move on. Your last step for this lesson is this page that's called Protons, Neutrons, and Electrons Practice. This is what you're going to take a picture of and attach to this lesson. There are a whole bunch of blanks that are filled in for you, and even more that need your attention. So using the periodic table, I need for you to figure out which elements these are, and then fill in the missing information. Of course, you are going to check answers up on my front counter when you're ready to move through all the questions.